through the rotor resistance starter. Control the speed of a 3-phase slipping motor by rotor resistance starter. Connect a 3-phase induction motor to an auto transformer starter. Control the speed of a 3-phase induction motor by an auto transformer starter. Let us discuss on speed control techniques on 3-phase induction motor.
Let us collect the tools, equipments, and machines required to do this practice.
Insulating cutting pliers 200 mm, 1 number. Connected screwdriver 100 mm, 1 number. Electrician's knife 100 mm, 1 number. Screwdriver 200 mm, 1 number. MI voltmeter 0 to 500 volt, 1 number. Tachometer 300 rpm to 3000 rpm, 1 number. Megger 500 volt, 1 number. 3-phase slip ring induction motor 415 volt, 3 HP. Rotor resistance starter complete set suitable for 3 HP. AC 3-phase squirrel cage induction motor 500 volt, 5 HP. Auto transformer starter complete set suitable for 5 HP. PVC insulated flexible cable 2.5 square mm, 20 meter. ICTP switch 10 ampere 500 volt, 2 number. Test lamp 40 watts, 250 volt, 1 number. Procedure. Task 1. Control the speed of a slip ring induction motor by a rotor resistance starter. Check the insulation and continuity of the motor winding. Set the megger to the appropriate voltage range for testing insulation resistance. Typically, a test voltage of 500 volt is used for low voltage motors. Disconnect all the motor leads from the power supply and any other connected devices such as motor protection devices or contactors. Connect one lead to the megger to the motor frame or ground terminal. Then connect the other lead to each motor winding terminal one by one. Record the insulation resistance readings for each winding. The reading should ideally be in the mega ohm range. If the readings are significantly lower or the megger indicates a fault, there may be insulation damage or moisture in the windings. Continuity test. Connect one lead of the megger to a known good ground point, such as motor frame, and use the other lead to test the continuity between each pair of motor winding terminals. The megger should indicate a low resistance or continuity for each winding. If there is an open circuit or a significantly higher resistance, there may be a broken conductor or a faulty connection. Make the connection as per circuit diagram. Connect the DOL starter to the motor stator terminals. DOL starter. It consists of a contactor, overload relay, and control circuitry. Identify the motor terminals. The motor will have 6 terminals labeled U1, U2, V1, V2, W1 and W2. U1, V1 and W1 are typically the incoming terminals, while U2, V2 and W2 are the outgoing terminals. Connect the motor's U1 terminal to the contactor's L1 terminal. Connect the motor's V1 terminal to the contactor's L2 terminal. Connect the motor's W1 terminal to the contactor's L3 terminal. Connect a jumper wire between the motor's U2 terminal and the contactor's T1 terminal. Connect a jumper wire between the motor's V2 terminal and the contactor's T2 terminal. Connect a jumper wire between the motor's W2 terminal and the contactor's T3 terminal. Connect the control circuit. The contactor will have specific terminals for the control circuit. These are usually labeled A1 and A2 or coil on the contactor. A1 is for the positive side of the control circuit and A2 is for the negative side. Connect the start and stop push buttons in series with the control circuit. Use control cables to connect one terminal of the start push button to the positive side of the control circuit. Example A1 on the contactor and the other terminal to the negative side of the control circuit. Example A2 to the contactor. Repeat the same for the stop button. For added safety, you can implement coil interlocking to prevent both the start and stop push buttons from being active simultaneously. Connect a normally closed contact of the stop push button in series with the start push button and vice versa. This means that when one push button is pressed and the other cannot be activated until the first one is released. Connect the rotor resistance to the rotor side of the slip ring induction motor. Identify the rotor terminals on the slip ring induction motor. These are typically found in a terminal box on the motor. Connect the resistors of the rotor resistance starter to the rotor terminals of a motor. Keep the rotor resistance starter handle in the starting position. Cut-in of the rotor resistance. Cut-in position of the rotor resistance is generally indicated in the starter as starting position or off position. Press the start button of the starter. While pressing the start push button, slowly move the handle of the rotor resistance from the starting position towards the running position step by step till it settles down at run position. Measure the speed at every step of rotor resistance and record. Release the pressure from the start push button. Press the off button of the starter to stop the motor. Control the speed of three-phase induction motor by an auto transformer starter. Make connections as per diagram. Identify the three-phase motor terminals labeled U, V and W. Connect the primary side of the auto transformer to the power supply. Connect the secondary side of the auto transformer to the motor terminals U, V and W. Connect the control circuit with start and stop push button switches. Ensure the knob of the three-phase auto transformer is at the minimum position. Switch on the main switch S1 and then press start push button. Keep auto transformer for 100 volt output. Start moving the auto transformer starter contacts such that the induction motor will start getting more voltage in stages up to full voltage. Note the speed and voltage at every stage. Reduce the applied voltage to the induction motor by resetting the auto transformer contacts. Measure the RPM of the induction motor at every stage and note in tabulation. Switch off by pressing stop button and then switch off the main switch S1. Conclusion. State in what proportion the speed changes with respect to applied voltage to induction motor. Recap. In this video, so far we have discussed how to control the speed of a slip ring induction motor using rotor resistance starter and squirrel cage induction motor using auto transformer starter. Thank you for watching. Have a good day. Hello everyone. In the last class, we discussed how to insert the coils in the slot in proper sequence, record winding data and stripe the winding, prepare a stepped core, lay coils, assemble and test the motor. Task 1. Calculate windings for the developed diagram. For easy understanding of the steps, a 24 slots, 24 coil, 4 pole, 3-phase motor is considered as an example. For the motor given as an example winding calculation or as under: number of coils per phase equal to total number of coils divided by number of phases equal to 24 by 3 equal to 8 coils by phase. 2. Number of coils by phase by pole equal to total number of coils divided by total number of phases into number of poles equal to 24 divided by 4 into 3 equal to 2 coils per phase per pole. 3. Pole pitch equal to number of slots divided by number of poles equal to 24 divided by 4 equal to 6 slots per pole. 4. Coil pitch possible: A. 5 1 to 6 short corded, B. 6 1 to 7 full pitched, C. 7 1 to 8 long corded. 5. Coil pitch selected equal to 5 1 to 6 6 coil pitch selected in short corded. 7. Total electrical degrees equal to 180 degree into number of poles equal to 180 degree into 4 equal to 720 degree. Slot distance in degrees equal to total electrical degrees divided by number of slots equal to 720 divided by 24 equal to 30. 9. Required displacement between phase in terms of slots equal to 120 divided by slot distance in degrees equal to 120 divided by 30 equal to 4 slots. 10. Winding sequence. If first phase starts in the first slot, second phase starts in the 1 plus 1, that is in fifth slot. Third phase starts in the 5 plus 4, that is in ninth slot. 11. Arrangement of coils. The coils are to be arranged in the slot in the sequence 1 to 6, 2 to 7, 3 to 8, 4 to 9, 5 to 10, 6 to 11, 7 to 12, 8 to 13, 9 to 14, 10 to 15, 11 to 16, 12 to 17, 13 to 18, 14 to 19, 15 to 20, 16 to 21, 17 to 22, 18 to 23, 19 to 24, 20 to 1, 21 to 2, 22 to 3, 23 to 4, 24 to 5. Task 2. Prepare the stator to receive the winding. Set the core if it is mangled. Lightly tap with the nylon mallet to correct the core and clean the slot to remove any old insulation paper. Select the insulation paper of the same grade and thickness or its equivalent as in the original and cut the insulation paper to the same size. Slot insulation paper must be approximately 10 to 15 mm longer than the slot length and is to be formed according to the shapes of the inner walls of the slot. The ends of the insulation are often cuffed to avoid the insulation paper from sliding off from its position. Task 3. Prepare coils. Make a ganked former or select a ready-made former according the old coil size. Select the correct size of winding wire as per the data taken. Attach the former to the winding machine. Wind the designated turns and make one set of ganked coils. Insert the ganked coils in the designated slots and check their correctness. While checking, make sure that the coils are of the correct dimension so that the two coils sides should be accommodated as top and bottom coil sides in the same slot of the double layer winding, and the overhang dimensions are comparable to the template as in the original. Make necessary sets of ganked coils if coil dimensions are correct. In the example given, two coils are forming the gank. Choose the former according to the number of gank coils. Task 4. Lay coils in the double layer winding. Carefully examine the developed diagram in which the slot pitch is given as 1 to 6 and there will be two coils in a group. The left coil side of coil 1 is in slot 1 as bottom coil and the right coil side of coil 1 is in slot 6 as top coil. In double layer winding, the coil sides should be placed in adjacent slots. Modify the procedure to suit the requirement of the given motor winding. Insert the left coil sides of the first set of ganked coils in slot 1 and 2. Leave the right coil sides of the ganked coils over the stator with the leatheroid insulation paper between the coil sides and core. Insert likewise two more sets to ganked coils in slot number 3, 4, 5 and 6 like step 1 and 2. Place a separator insulation over the bottom coil side of slot 6. Insert the right coil side of the first coil in slot number 6 as the top coil side. Task 5. Connect group leads, testing and varnishing. Bring out the group ends, connect, solder and insulate the groups. Connect the lead cables to the group connections and solder them. Tie the hemp threads in the overhangs to secure the sleeved joints and face separator insulations. Shape the overhangs and check with the template. Test the windings for continuity and earth faults. Assemble the motor if the test results are satisfactory and run it for 10 times. Dismantle the motor, impregnate the windings and dry them. If the results are okay, assemble and test the motor on load. Recap. In this video, we have discussed how to calculate winding for the developed diagram, prepare the stator to receive the winding, lay coils in double layer winding and connect group leads for testing and varnishing. Thank you for watching. Have a nice day. Hi everyone. I hope this video finds you well. In this video, we are going to discuss briefly about maintain, service and troubleshoot the AC motor starter. Objectives. At the end of this video, you will be able to number 1. Identify the parts of the AC starters. 2. Trace and draw the schematic diagram of the starters. 3. Check the volt coil, moving contactors, fixed contactors, NC and NO. 4. Set the overload relay and timer. Let us discuss the necessity of starters for motors. When an AC motor starts, it requires a surge of current to overcome inertia and get the rotor moving. The initial current can be several times higher than the motor's rated current, which may cause significant stress on the motor windings and the power supply. Starters are designed to limit the starting current and gradually ramp up the motor's speed, reducing the risk of electrical overload and minimizing voltage dips in the power supply. Select the tools and equipments required to do this practical. Combination pliers 200 mm, 1 number. Screwdriver 200 mm, 1 number. Multimeter 1 number. Mega 500 volt 1 number. Direct online starter 1 number. Star delta starter 1 number. Rotor resistance starter 1 number. Auto transformer starter 1 number. ICDP switch 16 ampere 500 volt 1 number. TPIC switch 16 ampere 500 volt 1 number. Push button station 1 number. Overload relay 1 number. Contactor 1 number. Procedure. Task 1. Check and service AC motor starters. Identify the parts of AC starters like contactor, unit, overload relay unit, start or stop push button unit, necessary fixing screws, hookup cables, starter base cover and timer. Investigate and check the contactor's input and output terminals, auxiliary and main terminals, movable and fixed contacts, no volt coil, overload relay, their rating, normally closed relay contacts and their operation. Identify the connecting terminals for interconnecting no volt coil, main supply to control circuit, normally open auxiliary contacts. Do not tighten the screws more than necessary, as too much tightening of screws will break the PVC casing of the contactor and OL relay. Draw the complete circuit diagram for DOL starter, star delta starter, rotor resistance starter and auto transformer starter. A complete diagram showing the internal diagram of a starter of a particular make along with ICTP and motor is given for your guidance. Set the overload relay and timer. Identify the full load current FLC of the motor. This information is typically available on the motor's nameplate. Choose an appropriate overload relay with a current rating slightly higher than the FLC. The specific model and type of overload relay will depend on your motor's requirements. Step 6. The timer in a star delta starter provides a time delay during the transition from the star configuration, low voltage, high current, to the delta configuration, full voltage, low current. This helps reduce inrush currents and mechanical stresses during motor starting. Determine the appropriate time delay required for your specific motor and application. Typical time delays range from a few seconds to a minute depending on the motor size and load. Maintenance of DOL starters. Starter check chart trouble. Number 1. Contacts chatter. Cause. Low voltage. Coil is not picking up properly. Broken pole shading ring. Poor contact between the pole faces of the magnet. Poor contact between fixed and movable contacts. Remedy. Correct the voltage condition. In case there is persistent low voltage, replace, clean the pole faces, clean contacts and adjust if necessary. Trouble. Number 2. Welding or overheating. Cause. Low voltage preventing magnet from sealing, abnormal in rush current, short circuit in the motor, foreign matter preventing contacts from closing, rapid inching. Remedy. Correct the voltage condition. In case of persistent low voltage coil, check excessive load current or use larger contactor. Remove the fault and check to ensure that the fuse rating is correct. Clean contacts with suitable solvent. Install larger device or caution the operation not to operate the inch button too quickly. Trouble. 3. Short life of contact points. Cause. Weak contact pressure. Remedy. Adjust or replace contact springs. Trouble. 4. Noisy magnets. Cause. Broken shading coil, magnet faces not mating, dirt or rust on magnet faces. Remedy. Replace magnet, align or replace magnet assembly, clean with suitable solvents. Trouble. 5. Failure to pick up. Cause. Low voltage, coil open or short circuited, mechanical obstruction in the moving parts. Remedy. Check system voltage. In case persistent low voltage, change to a lower voltage. Replace the coil. Clean and check for free movement of contact assembly. Trouble. 6. Failure of moving mechanism to drop out. Cause. Worn or rusted parts causing binding, residual magnetism due to lack of air gap in magnet path, gummy substance on pole faces causing binding. Remedy. Check wiring in the NVC coil circuit. Replace parts. Replace worn out magnets or demagnetize the parts. Clean with suitable solvent. Trouble. Overheating of coil. Cause. Over voltage short circuited turns in coils caused by mechanical damage of corrosion, high ambient temperature, dirt or rust on pole faces, increasing the air gap. Remedy. Check and correct terminal voltage, replace coil, relocate starter in a more suitable area or use a fan, clean pole faces. Overload relay or release. 1. Starter is tripping often. Incorrect setting of overload relay, sustained overload. Reset properly. Check for faults, excessive motor currents. 2. Failure to trip, causing motor burnout. Wrong setting of oil relay, mechanical binding due to dirt, corrosion, etc. Check oil relay ratings and set a proper relay. Clean or replace. Incorrect control wiring. Check the circuit and correct it. Fuses. Number 1. Constant blowing of fuses. Short circuit or poor insulation winding or wiring. Check the motor and the circuit for insulation resistance. 2. Fuse not blowing under short circuit condition. Fuse rating too high. Replace with suitable fuse. 3. Fuse blowing off frequently. Fuse rating too slow. Overloading of feeder. Replace with suitable fuse. Recap. In this video, we have discussed how to identify the parts of the AC starter, trace and draw the schematic diagram of the starters, check the volt coil, moving contactors, fixed contactors, NC and NO, set the overload relay and timer. Thank you for watching. Have a nice day. Hello friends, in today's class, let us learn how to identify parts and terminals of different types of single-phase AC motors. Objectives. At the end of this video, you will be able to read and interpret the nameplate details of the given single-phase AC motors, identify their parts and write their names, identify the pairs of two windings of 3 terminals and 4 terminals of a single-phase motor, measure the resistance of each winding with an ohm meter, OHM meter. Let us collect the tools and machines required to do this exercise. Trainees toolkit 1 number, ohm meter or multimeter 1 number, induction start induction run motor 1/2 HP 240 volt 50 Hz 1 number, single phase capacitor start induction run motor 1 HP 240 volt 50 Hz 1 number, universal motor 240 volt 50 Hz 0.5 HP 1 number, repulsion motor 240 50 Hz 0.5 HP 1 number, bipolar stepper motor 6 volt per 1 ampere, permanent magnet type 1 number. Procedure. Task 1. Identify the parts of single phase induction start motor or split phase motor. Read and interpret the nameplate details of the single phase induction start induction run motor and note down in tabulation. Nameplate details. Identify the parts of single phase induction start induction run motor from the real objects or from the exploited view chart. Each and every part is identified in the scene. Task 2. Identify the parts of capacitor start induction run motor. Read and interpret the name details of the capacitor start induction run motor and note down in tabulation. Identify the parts of the capacitor start induction run motor from the real objects or from the exploded view. Each and every part is identified in the scene. Identify the parts of single phase capacitor start, capacitor run motor, or permanent capacitor motor. Identify the parts of single phase capacitor start, capacitor run motor, or permanent capacitor motor. Read and interpret the nameplate details for permanent capacitor motor and note down in tabulation. Identify the parts of the permanent capacitor motor from the real objects or from the exploded view. Identify the parts of universal motor. Read and interpret the nameplate details of the universal motor and note down in tabulation. Identify the parts of the universal motor from the real objects or from the exploded view. Identify the parts of repulsion motor. Read and interpret the nameplate details of repulsion motor and note down in tabulation. Identify the parts of repulsion motor from the real objects or from the exploded view. Identify the parts of stepper motor. Step 1. Read and interpret the nameplate details of the stepper motor and note down in tabulation. Nameplate details: manufacturer, trademark, type, model or list number, type of current, function, fabrication or serial number, type of connection, rated voltage, rated frequency, rated power, rating class, insulation class, rated current, rated speed, protection class. Identify 3 terminals of the pair of 2 windings of single phase split phase induction motor. Remove the terminal cover. Make connection using a piece of cable and short circuit 2 terminals at a time to discharge the capacitor. Remove the capacitor if any and test the capacitor for insulation and leakage. Measure the resistance in between pairs of terminals by an ohm meter or multimeter. Mark the terminals between which you get maximum reading as 1 and 3. Mark the unmarked terminal as 2. The reading between the pair of terminals 1 and 2 and 1 and 3, whichever is greater, is considered as the terminals of starting winding and the other is considered as terminals of running winding. Record the resistance values in tabulation according to your terminal marking made. Identify 4 terminals of the pair of 2 windings of single phase split phase induction motor. Remove the terminal cover. Make connection using a piece of cable and short circuit 2 terminals at a time to discharge the capacitor. Remove the capacitor if any and test the capacitor for insulation and leakage. Measure the resistance in between pairs of terminals by an ohm meter or multimeter. Find out the pairs of terminals and number 1 pair of terminals as 1 and 2. The other pair is numbered as 3 and 4. Measure the resistance between U1 and U2 and Z1 and Z2. Conclusion: higher resistance is between 3 and 4 terminals. Lower resistance is between terminals marked as 1 and 2. Therefore, the starting winding is connected between high resistance between 1 and 2 equal to 21.1 ohms. Main winding between resistance between 3 and 4 equal to 8 ohms. Recap. In this video tutorial, we have discussed how to identify the parts of a single-phase motors and identify the pairs of two windings of 3 terminals and 4 terminals of a single-phase motor. Thank you for watching. Have a good day. Hello friends, in today's class, let us discuss how to install, connect and determine the performance of a single-phase AC motor. Objectives. At the end of this video, you will be able to read the manufacturer's installation instructions and follow them, transfer the template measurements to the mounting base, make the template for the base mounting of the given motor, frame wooden making, marking, drilling, selecting the hole size. Masonry tools like travel spirit level, etc. 1 set. Drilling machine electric 12.7 mm capacity with drills 1 number. Measuring tape 3 meters 1 number. Electrician hand tool kit 1 set. Spanner set 5 mm to 30 mm 1 set. Ball peen hammer 500 gram 1 number. AC single phase motor 0.5 HP 240 watt 1 number. Connecting cables as required. Plywood 8 mm thick 40 into 30 centimeter 1 number. Nuts, grounding bolts as required. GI wire 14 SWG 6 meters. Procedure. Task 1. Installation of single-phase AC motors. Read the nameplate details and record in the motor maintenance card. Nameplate details: voltage, phase, type, rating, speed, power factor, current, serial number. Make necessary arrangements at the place where the motor is to be installed as per manufacturer's nuts and bolts or and RCC foundation, etc. Determine the size of the connecting cable and fuse from the rating of the motor. Fuse current rating will be 2 or 3 times more than running current. If it has the dual function of overload protection also, the rating should be as recommended by the manufacturer or as per 1.5 recommendations. Calculating fuse ratings of motors. Motor type. Multiply the running current of the motor by single phase squirrel cage full voltage start 3, squirrel cage reduced voltage start or high reactance type if motor is rated at 30 ampere or less 3. Cut 2 straight pieces and 2 cross pieces of plywood and mark the holes accordingly to the size of the holes of the base of the motor on the wooden frame planks. Select the size of the drill according to the size of the mounting bolt as recommended by the manufacturer. Drill the holes according to the size mentioned. Make use of the template measurements on the mounting base and get the base mounting ready for installing the motor. A. Fix the planks with the grouting bolt. B. Check for level using the sprit level. C. Fill the space around the bolts with thin coarse cement mortar. In the training institute, use clay mortar instead of cement to facilitate repetition easily by every trainee in a batch. D. Allow it to settle down for 8 to 12 hours, then remove the template planks. E. Cure the cement mortar with water for a minimum of 2 days. F. Finish the surface by plastering neatly. Include vibration arresting devices as per the manufacturer's instructions, such as spring, washers, etc. Install the motor and fix it with nuts. Make double earthing in accordance with IE regulations and IS recommendation. 1. Identify the earthing terminal in the motor's terminal box or the frame itself. It is usually marked with the Earth E symbol. 2. Connect one end of the GI galvanized iron earthing wire to the motor's earthing terminal. 3. Connect the other end of the earthing wire to a suitable electrical ground, such as grounding busbar in the electrical distribution panel or a designated earthing point provided by the building's electrical system. Install the grounding electrode, a copper rod or plate, into the ground outside the building. Hammer the grounding rod into the soil until it is fully buried, leaving only a portion exposed above the ground. If using a grounding plate, bury it in a trench, ensuring good contact with the soil. Connect one end of a separate GI earthing wire to the grounding electrode, rod or plate. 7. Connect the other end of the wire to the motor's metal frame, ensuring a tight and secure connection. Check the continuity of the windings using Merger and also check the effectiveness of grounding. Set the merger to the appropriate voltage range for the motor you are testing. Connect the merger leads to the motor windings you want to test. Once everything is set up, start the merger test by triggering the instrument. If the merger reads very low resistance, the continuity between the windings is good. If the resistance value is high, then there is no continuity between the windings. To check the insulation resistance of the motor, place the merger probes between the winding terminals and the body of the motor and drive the merger. Normal windings should have a high resistance value, typically in the megaohm range, indicating good insulation. If the resistance value is very low or near zero, it indicates a short circuit in the winding. Step 11. Switch on the power supply to the motor and ensure it is running. Recap. In this section, we have discussed how to determine the performance of a single phase AC motor. Thank you for watching. Have a wonderful day.
Hello everyone, in this video let us learn how to start, run and reverse the direction of rotation of single phase AC motors. At the end of this video, you will be able to
start, run and reverse the direction of rotation of induction start and induction run motors through the direct online starter, capacitor start and induction run motors, capacitor start and capacitor run induction motors, repulsion motors and stepper motors.
For ease of learning, we will split this exercise into two parts. Part 1 will consist of Objective 1 and 2. Part 2 will include Objectives 3 and 4.
Let us collect the tools, equipment and machinery required for this practical. Electrician toolkit, pulley puller, moving iron voltmeter, moving iron ammeter, megger, single phase induction start, induction run motor, DOL starter for single phase motor, capacitor start, induction run motor, capacitor start, capacitor run motor, repulsion motor, bipolar stepper motor, regulated power supply, GI wire, PVC copper wire, ICDP switch. Start, run and reverse the direction of rotation, that is DOR, of induction start, induction run motor through DOL starter. Draw the complete connection diagram of the given motor, starter and ICDP. Identify the starting and running windings. Most single-phase induction motors have two windings, the starting winding and the running winding. The starting winding is used to provide the initial torque required for the motor to start, while the running winding is used to keep the motor running once it reaches its operating speed. Set the multimeter in resistance mode. Measure the resistance value of both windings. The lowest value among the windings is the main winding and a high resistance value indicates the starting winding. Connect the motor through the ICDP switch and starter as per the approved diagram across the AC rated voltage supply. Provide earth connection to the motor, the starter and the switch. Connect the incoming phase, that is line wire, and the neutral wire from the power supply to the corresponding terminals on the DOL starter. Connect both ends of the motor's main winding, that is U1 and U2, to the outgoing terminals of the DOL starter. Connect the motor's starting windings, that is Z2 and Z1, parallel to the main winding as shown in the circuit diagram. Replace with a fuse of proper capacity according to the motor rating and set the overload relay of the DOL starter to the current rating of the motor. Switch on the ICDP switch and press the start button of the starter. Check the direction of rotation and record it below. The direction of rotation is clockwise. Stop the motor by pressing the stop button, switch off the ICDP and remove the fuses. The ICDP switch must be switched off and the fuses removed before any modification in the circuit is carried out. Connect the starting winding terminal Z1 to U2 of the main winding and Z2 of the starting winding to U1 of the main winding as shown in the circuit diagram. Fix the fuse carrier in the fuse holder, then switch on the ICDP, press the start button in the DOL starter and observe the direction of rotation as anti-clockwise. Switch off the motor, reconnect the starting and main windings back to their original positions and now just interchange the main winding terminals alone. Start the motor and observe that the direction of rotation of the motor which is clockwise. Conclusion. From this, it is clearly observed that the direction of rotation of an induction start, induction run motor can be achieved either by interchanging the main winding or the starting winding, but not both. Start, run and reverse the direction of rotation of single-phase capacitor start induction run motor. Identify the motor terminals and make the connection as per the circuit diagram. Earthing the ICDP switch, starter and motor is most essential. Connect the input power supply to the DOL starter and from the DOL starter to the motor terminals through the ammeter and voltmeter in series and parallel respectively as shown in the circuit diagram. Connect the U1 running winding terminal and the Z1 starting winding terminal together and connect them to the phase or one end of the ammeter. Connect the centrifugal switch and capacitor in series with starting winding terminal Z2 and other end of the capacitor terminal to U2 and then to the neutral. provide fuse wire according to the rating of the motor in the ICDP switch and set the overload relay ampere in the DOL starter to the rated value of the motor. Switch on the ICDP, start the motor with the help of the starter and note the starting current, normal running current and the direction of rotation and enter the details in tabulation. For changing the direction of rotation, stop the motor by using the starter and switch off the ICDP and remove the fuse carrier. Interchange either the starting winding or the running winding terminals for changing the direction of rotation. Connect the running winding terminals U1 to Z2 of the starting winding terminals and Z1 of the starting winding in series with the centrifugal and capacitor. Insert the fuse carrier into the fuse holder in the ICDP switch and start the motor by pressing the start button in the starter. Check the effect on the direction of rotation and record the result in tabulation. Conclusion: the direction of rotation of a single-phase induction motor can be changed either by interchanging the main winding terminals or the starting winding terminals, but not both.
This concludes part 1 of this exercise. We will continue in part 2.
बच्चों के इंटरनेट सेफ्टी के लिए 5 टिप्स। पहला, अपनी व्यक्तिगत जानकारी जैसे कि आपके घर का पता, स्कूल का नाम और फ़ोन नंबर किसी को भी ना दें। दूसरा, अनजान लोगों को अपने फ़ोटोज़ ना भेजें। तीसरा, अपने पेरेंट्स के सिवा सभी से अपने पासवर्ड को प्राइवेट रखें और शेयर ना करें। चौथा,